Hi, in this video I'm going to talk about 3 necessary techniques that you will most likely encounter whenever you're working on a programming problem. I'm also going to be showcasing a specific exercise in this video that shows these 3 techniques in action. So let's just get into it. Alright, so the first technique that I'm going to talk about is divide and conquer. As you can see, we have a problem here. We divide it into several parts, so we call it a subproblem. And then we solve these subproblems all together and then combine them, and what we have at the end is the solution to the problem. So whenever you're facing a challenge or an exercise or whatever that you're dealing with, your best bet is to divide it into several parts, solve those parts separately, and then you combine all those parts together, and then you get the full picture or solution to your problem. So this is the first technique that you will 90% of the time end up using whenever you're dealing with a programming problem. The second technique is called digging graves. So whenever you want to bury a body or whatever you want to bury in a grave, you have to first dig a grave or dig a hole. So as you can see, you have to make the foundation first and then bury the body. I will show this specifically when I'm going to be showcasing the exercise. But the last technique that we have is called modularization. Now, what is modularization? Modularization is breaking a large problem into modules or several parts. I mean, it's the same as divide and conquer. So it's like organizing your code, and it's like putting them in boxes. And whenever you want to do something or perform a certain operation, instead of just writing the code all the way again and again and again, you just open that box or simply just call that function. Now, this approach has, as you can see, it has several advantages. So what are the advantages? It provides abstraction, allows multiple programmers to work simultaneously, allows code reuse, which is the most important point here, and makes identifying structures easier. So as you can see, modularization makes life way more easier. I'm going to show that in the exercise that I'm going to showcase in this video. Alright, so let me open up the challenge here. Let's see what we have. Alright, so there's our challenge here. It says, write a program that prints this message at the beginning of the program. I explained what each option should do. P prints numbers, A add numbers. So we have, multiple options here. And based on our input, it's going to carry out certain operations. So for example, P is going to print numbers, A is going to add numbers, M display the average of numbers, S the smallest, L the largest, E the sum of numbers in the list, C is going to clear that list, F is going to find the number, and Q is obviously going to quit the program. So when I read this option, I see that we have a program that's going to run infinitely until we hit Q, and then the program is going to quit. But let's read carefully what each option is going to do, because sometimes when you don't read something completely, then you find out, oh, wow, the challenge had something else to do. So P is going to print the numbers available in the vector, and if the vector is empty, the program should print this message as it says here, the list is empty. If the vector is not empty, the numbers should be printed in this manner. So something like this, for example. A is going to add numbers to your vector based on your input. So basically we have a vector here. I mean, the challenge is specifying it completely. If the number that you enter already exists in the vector, the program should print number is already on the list and then goes back to the selection input. So it's not going to add the number if it's already on the list. M is going to print the average of the numbers. I mean, this is very obvious. S, L, E, these options are very obvious. I mean, there's nothing much going on here. C is going to clear the list completely, making it empty. If so this option is going to ask for your input. If the number doesn't exist in the vector, it should print out this message and a number does not exist, and then goes back to the menu selection. And if the number is available, the program should print this message and the number is available. And then after that, it should print the index for which this number exists in that vector. So not only is going to tell you that the number is available, it's also going to tell you the index for which the number is available. And then finally, Q is going to quit the program. But there's also more. See, this is what I mean, that you should read something completely and carefully. To spice things up and make things interesting with this challenge, I want the program upon quitting to store the results in a text file. If the vector is empty, then no text file shall be created. The results should be stored in this manner, something like this. So this is the output of your text file. This is what should be in that text file. So for example, let's say you have entered a bunch of numbers. It's going to add this line into your text, and then how many numbers you have entered, the sum of them, largest, smallest, and then the average. Make sure your code is modularized. One thing to note, this program runs until the user enters Q to quit. So yeah, it's also stating that this is a while loop. Good luck and happy coding hours. All right, so here's what we're going to do. We're going to divide this problem into several parts. First part, I'm just going to write them here. Just make a to-do list. So the first thing that you're going to do is printing main menu. So every time when the program is running, it should print out the main menu. But I have a better solution to printing main menu, because every time you're going to print that menu, things are going to get very messy in the console application. So second thing you might want to do is to clear the console, which is upon user input. So every time, for example, you enter P or A or whatever one of these options, the console is going to be clear, and the corresponding message is going to be shown on the console, and then you're going to carry out that operation. So basically, it's just going to make your console very clear, very neat. And then the third part, so basically we have several options here. What we're going to do is basically digging the graves. This is what I meant previously by digging graves. We're just going to use a switch case. So number 3 is going to be switch case for each possible input. So for each of these, we're going to first dig the grave. Let me digging the graves. And of course, what we're going to do throughout all these steps, we're going to make sure our program is modularized. Of course, we don't want to leave things in an unmodularized way, because otherwise things are going to get very, very messy, and you're going to end up in a lot of confusion. So after that, we're going to do modularization for each option, or basically carrying out each option. So for each of these options, we're going to make a separate function, and then we're going to define what each function should do. Next, we have adding numbers. Let's say, for example, what this option is expecting from you is that you enter a number. But let's say, for example, you enter something like, I don't know, base 1, 2, 3, 4, or something like that. So this is going to be invalid input. So what we're going to do we are going to do input validation as well, because otherwise things are also going to get tricky and also a bit messy. So we need to apply that input validation. I mean, in our switch case, we can apply that because we're expecting to be entering letters here. So we can do that with the default case. I'm just going to show you right away. But for this specific option, which is adding numbers, we need to apply as as like something like an input validation, so things don't go wrong. And then finally, last but not least, is going to be file writing, because as it says, I want the program upon quitting to store the results in a text file. So this is going to be our last operation. So this is the basic, to-do list, or I would like to call it divide and conquer. This is what we're going to be basically doing. We're going to carry out each of these operations, each of these uh, tasks separately, until at the end we get the full picture and then solve this entire problem in its entirety. So let's just get into it. All right, so first thing I'm going to do is just get rid of this, because this is a bad idea. I think there's an explanation behind it, because using namespace std is going to import um, all of those symbols in the std library that we're not going to use, and it's going to impact our performance. So it's best to avoid that. All right, so what we need a set of variables that I'm going to define, and also a while loop. I'm going to define a Boolean variable and call it state, and it's going to be true. This is for the state of the program. So while this state variable is true, we're going to carry out these operations. And then obviously we need an input. So we're going to declare a char variable. We're going to name it input, and then I'm going to declare it to be something empty. I don't want any value. It's always a good idea to initialize your variables, because sometimes when you don't, things might get out of hand and you're going to run into trouble. So first thing we need to do is printing the main menu. What you can do to make sure your source code is readable is that you're going to use meaningful commenting. Too much commenting can cause a lot of headache. I don't suggest that you do that, but do it in a way that you know where certain things are. So for example, here I'm going to write a comment to say that here are my header files. So header files are going to go down here, and then I'm going to write another comment which is going to be the functions. Here functions are going to go down here. So we need to print the main menu. We're going to declare a function and call it main menu. So I'm naming it main menu. And so we're going to be printing this whole thing together. And we can do that with just one single cout call. And you just need to do this for each of them. I'm going to fast forward the video because this is going to be time consuming. All right, so this is basic foundation for our main menu. This is going to be our main menu here. So every time this while loop is going on, it's going to call main menu. So it's going to display the whole menu for us. And then we have the call to enter your choice here. And then what we're going to do is going to ask for input. And then at the end, what we're going to do is going to be doing a switch case. So switch is going to be for our input, and we're going to check it for each case. Although I'm going to be showing you to do something to this input, because let's say our options are in capital letters. So if, for example, you enter small letters, what you're going to do is going to convert that into a capital letter. So what we're going to do is going to be using the toOpper function, and we're going to give it our input variable. So regardless of whatever you enter in the console as your input, is going to convert that into a capital letter. So right now we're going to be doing a check for each of these cases. Again, I'm going to fast forward the video because this is going to be time consuming. All right, so we defined each case for all the other options. So what we're going to do, we're going to be defining a default case. This is going to be for cases when the user enters something out of the line, which is invalid input. So we're going to be giving a cout call. This is going to be invalid input. Please try again. So this is the very basic foundation for our program. So for each case, we're going to be defining a function, and we're going to be defining the functions all over here. Of course, there's going to be some header files that we're going to be using. So this is basically the general case here. All right, so we did the deal with the main menu situation. So right now we need to deal with the clear console. So what we're going to do, again, I'm going to be declaring a function. I'm going to call it clear console. And I'm going to be using a specific code here. This function is going to be working depending on a specific operating system. So for example, if you're on Windows, this is going to be a system call, which is going to be system CLS. But if you're, for example, on Linux or Mac OS, it's going to be system clear. So it's going to clears the console based on your operating system. So we're going to be writing if def in 32. This is going to be system CLS, and we're going to be giving it an else command. This is going to be then this is going to be the end if here. And for using these system calls, we need to be including a header file. The header file that we're going to be using for this specific operation is going to be cstdlib. So this is going to carry out the clear console operation. So as you can see, if you use Windows, this command is going to be running, and anything other than Windows is going to be Linux or Mac OS is going to be this command, and that this is going to end the if case here. This is a very special if case, and then this specific parameter here is defining whether you're on Windows or any other operating system. So, all right, this is the basic foundation here. What we're going to do is we're going to be clearing the console. I'm just going to show you how this program would look. So let's compile and run it. Okay, so basically we have an error here. Empty character console. Okay, so let's just initialize it to A or something like that, whatever it's going to be. So this is the menu, right? So I'm just going to, so anything other than the options presented that we enter is going to give us, invalid input. But see, each time this menu is being printed in the console, and as a result, it gets really messy. Also, I forgot to do one thing here in our queue case. Because we want the program to quit, we should set the state to false. So basically, instead of this operation here, we set the state to be false. So now if I run it, we're going to test it for each option, and then when I hit Q, it's going to quit the program, and then it's going to close. So instead, we're going to be running this clear console for each case. All right, so we did this whole thing here, and let's just build and run it. So right now when I type it's going to again clear the console and then print this again here. But as you can see, I've put this equal signs here. So for example, when you print the whole thing, it's going to print it on the upper hand of this whole message, and then it's going to print this whole menu again. We're going to be seeing this when we progress further and we write our code. All right, so for now, we dug the graves and it's time to bury the bodies. And for that, we're going to be doing some modularization, and we're going to be defining functions for each of these cases. So what we have is we need a vector, and for that we need to be including another header file, which is going to be include vector. I'm going to be defining a variable of vector with the type of double. I'm just gonna call it numbers. It's going to be empty. In our case of P, we're going to be declaring a function here, and for each case we're going to be doing that. Oh, one more thing that I just wanted to show you. I realized I made a very bad mistake here. As you can see, this is what happens when you just start coding and then you just realize your own mistakes too. As you can see, I've done some kind of code duplication here, and this is a bad idea. So in order to avoid that, you can basically clear the console after the input. So after you enter your input, it's going to clear the console, and then it's going to see what case you have. So I'm just going to be deleting each of them, and then as you can see, we're just clearing the console only one time, not with each case. So this is a common error that you will face whenever you're programming, and this is called code duplication. So I'm trying to avoid that as much as possible. So let's just go with each of these cases. right, so we have this print numbers function, and as we said in the challenge description, if the vector is empty, the program should print the list is empty, and if the vector is not, then the numbers should be printed out in this manner. So if we were using a special function from the vector group, which is dot empty, so this is going to it's a boolean function that's going to return either true or false. If your vector is empty, it's going to return true, and if not, it's going to return false. And if it's true, and if your vector is actually empty, it's going to be printing this message. Otherwise, we are going to be printing each of the value that are in our vector. So for example, uh, this is the parentheses that's going to be printed in the beginning. Then we have this for loop. If I want to translate it for whatever that is inside numbers vectors, call it x, you just print out the x followed by this comma. And then at the end, you're going to be printing this backspace characters, and then you're going to close the parentheses. I'm going to show you why I put these in here. So let's call this function, and we're going to be giving numbers. Oh, and by the way, our function is going to be taking a vector. So it's going to be checking based on the vector that we have declared in the main function. For instance, let's just add some numbers in our vector, for example, because I want to show you. Let me get rid of these, and let's see how it's going to show. Oh yeah, I forgot a semicolon. So okay, we have this menu here. I'm going to see when I say print the numbers, it's going to be printing the numbers, but it's going to leave out this space here followed by the last comma. We don't want that. So we just put the backspace characters here. We're going to go back 2 characters. We're just getting rid of this last comma. And then at the end, we are putting the closing parentheses. So yeah, that's the reason why I put these 2 backspace characters here, followed by the closing parentheses and then the new line. So now let's just run the program and see what we have. Let me first close, quit the program. Let's just run it. And as you can see, when I print the numbers, that's extra space and the last comma is not there. So this is the print function, or the case of P here. So next, we're going to be checking for adding numbers, because A is going to add numbers. So let's do that. All right, so far I wrote two functions, which is for print numbers and then adding numbers. Let me explain what I did for adding the numbers. For adding the numbers, we are going to do some sort of input validation. And in order to do input validation, one way, or should I say one best way to do that, is by using string streams. Let me tell you about a specific operator, which is the reference operator here. Whenever you're passing an argument and you're referencing something, you are actually going to make the changes to the actual variable that you declared. So for example, in this case, the ampersand followed by the numbers vector, whenever you are going to call that function, you are actually specifically going to be making those changes to this vector that you include. But if I don't put this ampersand here, then no changes will be applied to our vector, and all of this will be for nothing. So we need this ampersand if we want to apply changes to our actual variable or vector or whatever we're dealing with. So we have a number variable, and I declared this number to be a double because we're going to be adding some double values or floating point numbers. And we're going to be doing some sort of input validation in this if case. Here, I declared another function with the type of boolean, and I called it input validation. And the reason why this is boolean, because we are going to return either true or false. True if the input is actually a number, a legitimate number, and false if our input is not a number. How are we going to do that? First, you're going to ask for a number. So with the cout call, you're going to say enter your number. And then we declare another variable with the type of string. Oh, by the way, I forgot to mention that it's always best case to include string header file as well, because most of the time you're going to be using some string functions, and it's best to include that. So you have a string variable called input, and then you're going to ask for input. So what you're going to do is you're going to create a string stream, and you're going to call it ISS or iString stream, and you're going to give it the input. All right, so let me explain here how string stream basically works. So supposedly you have a string variable called input, and let's say we've initialized it to 1 2 3 4, and as you can see, it has the value 1 2 3 4 stored inside our string variable. Now we declare another type of variable, which is a string stream, and we name it ISS, and we inject input inside of this ISS variable. So our ISS variable, which is an iString stream, is going to have the same value as our input, which is 1 2 3 4. Now on the other hand, we have another variable which is an integer, and we've named it num, and we've initialized it to 0. And as you can see, value 0 is stored inside of this variable. Now the interesting part about string streams is that you can basically inject values into other variables. So as you can see, if we, for example, do ISS into num, so basically our num variable is going to take 1 2 3 4, and it's going to store that value inside itself, and it's going to return true. This is one case for our string input. Now, what if we have another value stored inside our input? Let's see the second case. All right, so the second case is, what if we enter something like 1 2 3 4 A B C D? So as you can see, our string input is going to be 1 2 3 4 A B C D, and if we inject it into our string stream, which is ISS input, our ISS is going to take that same value and store it inside itself. But the difference is if we do ISS into num, so we basically inject it into our num variable, it's going to take that 1, 2, 3, 4 and put it inside our num variable, and our ISS variable is going to only contain the part that wasn't basically removed. So our ISS is going to be ABCD. On the third case, I'm going to explain how we can basically avoid that and make sure that this whole thing doesn't actually work, because we don't want to enter something like this and take this part of the input and store it into our num. We want the program to basically give us an error and asking us to enter our input again. But what if we just do this whole thing but in reverse? Instead, we, for example, type ABCD 1, 2, 3, 4, and then again we inject it into our ISS variable, so it's going to take that same value. And if we do the ISS num, it's going to return false, because it's going to look at the first part of our ISS and it's going to see A. We can't inject A into an integer type because A is basically a character. So we can't do that. So num variable is going to stay 0 and our ISS is going to basically stay the same. So in this case, it's going to return false. But in this whole scenario, it's going to take the first part, which is the integer part, and it's going to basically inject it into our num variable and remain the rest of the input inside our ISS variable. So now on the third case, I'm going to explain how we can basically avoid that. Finally, on the third and final case, we have the same setup here, but instead there's something different. We do ISS into num and ISS.EOF. So basically EOF stands for end of file. And what this does is it's going to ensure that our ISS is basically empty. So for example, if ISS into num is successful, it returns true. So basically your num variable is going to be 1, 2, 3, 4, and your ISS is going to contain ABCD. So basically ISS.EOF or end of file is going to return false because, well, basically ISS contains ABCD and it's not empty. But in case if we just enter integers, this one is going to return true, and ISS.EOF is also going to return true. Why? Because the whole integer is going to be injected into our num variable and it's going to basically get to be empty. And so ISS.EOF is basically also going to return true. So with this combination, we can make sure that our input only and only contains integer. And this is how we can basically ensure input validation. Now, at the time of recording the whole clips back then, I realized that I made a mistake and I forgot to include this, simple basic parameter here, which is ISS.EOF. And I forgot to include that. So in case you're following along with the video and you're basically practicing, make sure that you also include that within this if clause. So basically ISS into num is going to basically inject the whole string stream into our num variable, and if it's successful, it's going to return true. And ISS.EOF is going to ensure if our ISS variable is empty, and if it's empty, it's also going to return true. And if it's not, which is the case, it only contains alphabetic characters, it's going to return false. And basically this if clause is going to fail and our else clause is going to take into effect and basically get executed, which is going to ask us to enter a valid number. So make sure you keep that in mind if you're following along with the video. So yeah, that's basically the whole thing that's going to happen. And also this is going to happen if you have a legitimate integer in your string variable. It's going to extract that into your num variable. So it's basically going to be putting the number into your variable, and then it's going to return true. When it returns true, that means that you have entered a good input. Otherwise, it's going to tell you that please enter a valid number, and it's going to return false. And this whole thing is not going to be executed at all. And it just, then again goes back to the main menu again. All right, so now that we have checked whether our input is valid or not, if it returns true and our input is valid, now we want to check if the number exists in our vector or not. So we're going to be using pointers here. I'm using a auto type of variable. Auto is mostly used for pointers and other types of variables that you don't know the type. So for example, if we call this number pointer, we're going to be using a function called find, which is in the std family. So find takes three elements: the beginning of your vector, the ending part of your vector, and then what you are trying to find. The first and the second argument of this function can be numbers, can be the index of your vector. I mean, for example, the begin and end is going to, as the name suggests, is going to look for that number from the beginning of the vector to the end of the vector. But for example, you can say, let's say you have 5 elements, right? And you want to only look through the first 3 elements. So for example, you can say 0 until 2. So it's going to look 0, 1, and 2, and it's going to look for that number. So this is just an example. So find is going to basically find your number, and it's going to return the address. So number pointer is going to be the address of that number. And then we're going to be doing an if else check. If your pointer is equal to the end, because if it doesn't find the number, it's going to point to the end of your vector, the ending address, or your last element. Not the last element, actually, one after the last element. Basically, the end function returns the element after the one element after the last element in your vector. So it's going to point to that address. What does this mean? This part is telling you, okay, the number does not exist in your list. Therefore, okay, you can add the number. So we place this message with the cout call that we added the number to the list, and then we're going to be pushbacking the number into your vector. Otherwise, so if your find function here actually finds the number and then points to an address, then we can say, okay, the number is already on the list, and well, you can't add this number to your list. So I'm going to also, I forgot to mention, std find requires the algorithm header file, and also istring stream requires the stream header file. So right now what I'm going to do, in our case, it's going to be add numbers, and we need to give it the vector here, which is the numbers. So let's just run this program. All right, so let me print the numbers first. I previously added these numbers. So we have 3 numbers, 12, 14, and 15. Let's say I want to add a number. It says enter your number. So let's add something else. For example, 16. So as you can see, it says added 16 to the list. And if I print the number, 16 is going to be the last element. Let's just add, for example, 12 that already exists in the list. 12 is already on the list. And by the way, I need to put a space here because these two are sticking together. So yeah, as you can see, it's pretty straightforward. Next, what we're going to do is I'm going to be implementing the M, S, L, and the rest. Here I declared another function called display average. Now, the way for calculating the average, we need to basically calculate the sum of all the values in our vector and then divide that by the size of our vector. And the size of our vector is going to be the number of elements in our vector. So we're going to be using a specific function which is called accumulate from the std family, which is very helpful. You can also do that instead of std accumulate. You need to be using a for loop, and you need to be declaring another variable, and then you're going to be adding all those elements together until you reach the ending point of your vector. And then when you have the sum, and then you're going to be dividing sum to the size of your vector. But that's a very hard approach. I mean, when we have this function, we can be using this one instead. In order to use the accumulate function, you need to be including this header file called numeric. So I'm just going to let you know that this is for std accumulate. So yeah, this is also the same for displaying the sum of numbers, because we have another option called E, which is going to display the sum of numbers. I'm going to be also implementing that in that function as well. So what does accumulate do? You need to give them the beginning and the end part of the function, and the last element is going to be the precision. If I leave this to 0, this is only going to return an integer, but if I type in 0.0, it's going to return a double. And we are dividing that by the size of our vector, which is the number of elements in our vector. So then it's going to return the average. So right now, I'm just going to be calling this function, and then I'm giving it the numbers vector. Let's just save it and run it. I mean, we have 3 elements here in our vector, so if I just press M, it's going to be calculating the average, as you can see. I'm going to be doing the same for the sum, and then I'll get back to you. All right, so I also did that for the sum function. Let's see how it goes. Now, if I just type in E, it's going to return the sum. Although our numbers are not floating point numbers, so it's going to return just basic integer. But let me actually quit the program. Let's just make one of them a floating point number. And if I run this, E is going to return a floating point number. Actually, in order to show you what I meant at the end, if I just make this into 0, and when I run it, as you can see, it's going to omit the decimal point, and it's just going to return an integer. But we don't want that, and I'm just going to change it back to 0.0 to return a floating point number. All right, so far, as you can see, I've done some great amount of modularization. I implemented some functions. I did input validation, and we also did some, showing the main menu. So from this to-do list, we did print the main menu. I'm just going to type, this character here, then the clear console, then modularization for each option. We're doing that. Input validation, we did that. And then switch case for each possible input, we have also done that too. So the last part is going to be file writing, which is when we want to quit the program. So now let's go over S and L, which is going to display the smallest and the largest numbers. Let's just do that. All right, so I've defined these two functions, which is smallest and largest. There is something that I want to show you, but before that, uh, I'm using a min element and max element here, and that requires the algorithm header file, so you need to include that as well. Uh, what this does is basically, I'm also going to be explaining why I included this star character here. So again, kind of like accumulate, or the find function is going to take the beginning and ending part of your vector, but this is going to return an iterator, or because this is an iterator, it's going to return the address. But if you want to actually access that address and access that value, you're going to be using this star character, so it's going to be accessing that value. So basically we're just going to be doing that. However, there's something that I want to show you, but first let me just run this program. Oh, by the way, I need to be calling these functions. So for L, this is going to be display largest, and this is going to take numbers, and then this is display smallest, and again it's going to take numbers as an argument. So let's just build and run. All right, so let me print the numbers first. So these are your numbers. Again, if I print M, it's going to print the average. If I print S, if I type S, it's going to display the smallest number, which is 12.3. So this is so L displays the largest number, so your largest number in the vector, which is 15, and if I type S, it's going to return the smallest, which is 12.3. However, now if I type E, it's going to also return the sum value. All right. However, if our vector is empty, let's just empty the vector. Now if I just build and run this program, and if I type, if I want to show the smallest number, if I type S, the program is going to crash. As you can see, it's just going to quit. So we need to basically check whether our vector is empty or not. And otherwise, if the vector is empty, we need to print some kind of message that says, oh, okay, your vector is basically empty and you need to maybe add some numbers. So let's just do that. All right, so I did an if else check here, and I'm checking whether the vector is empty or not. And if the vector is not empty, it's going to print the minimum element or the max element. Otherwise, we need to print a message saying no elements in the vector. So if we run that, now that the vector is empty, it's going to say no elements in the vector until I add some numbers, like for example 12.5. Let's just add another number like 13. And if I just press S, it's going to print 12.5. And if I type L, it's going to be showing me 13, which is the largest number. And you can see the program so far is working really, really fine. All right, so we're getting close to finishing this program. There are only 3 cases left, which is C that clears the list, F is going to find the number, and Q is just going to write the results in a file, and then it's going to quit the program. So let's just go into the C case here. All right, so I defined another function called clear vector. And if we take a close look at it, I reference the vector because I'm going to make direct changes to our vector variable. So we're going to be using vector.clear function, and it's going to clear the vector completely. So if I run this now, as we can see, if I just print the list is empty for now. Let's just add a number, for example 12.2, and if I print the number, it's going to show you 12.2 that I added previously. Now if I hit C, it's going to say cleared the list, and if I just type P, it's going to show you that the list is empty. Now we go to solve the F case, and then finally the Q case. All right, so I declared another function called find number, which is exactly the same as the add number function, which we were going to add the number to our vector. I mean, it's just the same, that it's going to check whether the number is on the list or not. The same principle can be applied here, except with a few bunch of differences. So once we find the number, instead of just seeing if the number pointer is equal to the end address, we say if it's not equal. So that means the number is actually available. And then in order to type out the index, we just calculate it with another function from the std family called distance. And what it takes is the numbers vector from the beginning, and I'm sorry, I made a small mistake here, and this should be the number that we have here. So up to the beginning of our vector until the number, so it's going to calculate that index. And in order to be a little bit more specific, I can say index, and this is going to be our index. So now if I just run this, all right, hold on a second. All right, so my mistake was that I included the number, whereas I should have included the address instead of the actual number. So these fields should be the address, not the actual number, because the begin and the end, they are all iterators. They return the address, not the actual value. If you want to access the actual value, you have to put a star behind it. So you need to call the function from here, and then you run it. Now if we run this, the list is empty. Let's just add some numbers: 45, I don't know, 12, 78. And if we printed this, these are the numbers that we have entered and added to our list. So if I type F, it's going to ask for my number. 12 is available, index 1, again 78, index 2. And if we type something that does not exist, it says 46 does not exist. All right, so we are getting close to the end of this, and we're going to be covering the last part of this exercise, which is writing the results to a file. and it's going to be very over soon. Now let's just get into it. All right, so I wrote another function called write to file, which is going to take the numbers vector, and we're going to check if the vector is empty or not. If the vector is empty, then there wouldn't be any results file created. And if it's not, then we're going to be creating a new file. And in order to be reading and writing to files, you need the header file called fstream. So you need to include that as well. And I'm also going to explain why I included this string in the first place. So you're going to be creating a new file, output file stream or OF stream, which is going to be named file. And then you're going to open your file, which is going to be results.txt, and then you're going to be including this last parameter at the end. What this does is when this is only useful when you want to basically append to the end of your file. If you don't include this, each time that you run this program, a new results.txt file is going to be created and replaced with the previous one. But instead, when you add this, no matter how many times you run it, the results are going to be included in the results.txt file, and it's just going to be added in the next line, basically appending to your file. So for each case writing to your file, I separated them with the corresponding comments. For example, for the numbers, this is the code that it's going to deal with the numbers. So it's going to basically type out the numbers, and then we have this for loop again, for meaning for every element named x in your numbers vector, it's going to be added to your text variable, which is a string. Because your x is a double variable, you need to be converting that to a string, and I'm basically including them in the text variable because at the end I'm going to be writing the text variable in the file. So it's a very convenient method. And also, because just like I described in the print numbers here, you have two backspace characters. Basically, you want to get rid of that extra space and the last comma. But the problem is you can't use the backspace. It's going to lead into some strange problems. I'll show you what I mean basically exactly. So you're basically going to pop back those extra space and the last comma, and then you're going to be writing the text into the file. Then you're going to be writing the count, the sum, just like the previous formulas that we used. And it's it's very, very similar to stdc out, but instead you do it with the file. At the end, you just put this line to basically summarize the whole results, and then at the end you close the file. So now if we run this, so this is the main menu again. You have no elements in the list. Now let's see if I quit. There shouldn't be any type of results.txt. As you can see, there is no text file. Now if I run it again, the list is empty. Let's add some numbers: 45, 12, and 78. So I added these 3 numbers. Let's just check the whole program in general. Let's run all the options here. So P is going to print the numbers basically. M is going to display the average. S is going to display the smallest. L is going to display the largest. E is going to display the sum of numbers. C is going to clear the list, but I'm not going to try that because I'm going to show you the text file that's going to be created at the end. And if we type F, and then if we look for the number, it shows you if the number is available or not. For example, as you can see, 789 does not exist. And if we hit Q, the program quits, but we have a new file. And if we open the file, this is the result. See, numbers. The only problem is this decimals that are following. So yeah, that's basically just the whole thing. And if I just run this again, let's run it again. Let's add, for example, another number and then call it quits. And if I open this, as you can see, it adds another section but at the end of this file and shows you the results. So yeah, that's basically pretty much it. This is the whole challenge that you can basically solve in this manner. So as you can see, we did the divide and conquer. We basically broke the problem down into several parts. We solved each of them, and as you can see, we got the whole problem solved all together, and we get the full picture. Then we also dug some graves and buried our bodies in those graves. And what I mean is, just for each case, we just dug those graves, and then we declared those functions. And as you can see, the whole code is very modularized, very, very clearly written, and you can actually see what's going on, how things basically work in this program. And yeah, that's basically. So I hope you enjoyed this video. Let me know if you have any questions or not, and I'll be glad to help you in that manner. Thank you very much.